So today's topic is two-way tables and conditional probability. Last time we were talking about a dice roll. One event was happening. We were talking about flipping a spinner or a coin. One event. If you look at this table right here, we're going to break it up into two different events, which is why it's called a two-way table. Event 1, you're going to choose BYU, U of U, neither. I had to add the neither because I know there are more people than me that really just simply don't care. Or are an Aggie fan. So I put in neither category. Okay, that one might just be me, but that's okay. Or male, female, total. So what we're going to do first, this is what a two-way table looks like. We first need to figure out how many male BYU fans we have and how many male U of U fans we have and how many don't care. So really quick, if you're a boy, stand up. Yeah, a very large percentage of this class is male. Raise your hand if you are, raise your hand if you're a BYU fan. 1, 2, 3.
Sports marketing class.
3 BYUs. Okay, if you're a BYU fan, sit down. Raise your hand if you're a University of Utah fan. 1.
All of us got different teams.
1.
UCLA.
Oh, heck yeah, bro.
Raise your
Wins
hand.
all the way.
Carson, what are you?
Raise your hand if you're neither.
Gene, what are you?
1, 2, 3, 4, 5, 6, 7, 8, 9. Well, maybe this isn't going to go the way I thought it would. All right. Thank you. Ladies, stand up. All right.
She's Notre Dame.
BYU.
She's Notre Dame.
BYU 1. The U.
Because they're
1. Neither. 4. Okay, thank you. Go ahead and fill it in. There's a lot of people that just don't care.
Well, I just don't.
All right, so we talk about the totals.
Maybe not.
Yes, which is why our class is always so loud.
Hey, that's
against the stereotype.
Not people
13,
that don't care, it's people that
6.
like other teams.
Yeah.
Wait, how's that against stereotype?
No, we're saying it's loud because there's a bunch of boys.
Wait, there's only 19 people in our class?
Today, there's more normally.
Okay.
I think there's like 25, but we've got kids absent.
Chase is going.
Total,
That's what
4, 2, 13. Now, when you add them vertically, horizontally, they both should equal 19. They do. All right, anytime throughout the day that we call the count, if we're referring to the count, we counted there were 3 BYU fans, boys, right? The count was 1 here. The count was 9. That's what it's referring to. Okay, so now what we're going to do is we're going to record the data using the relative frequency. That word means the percentages. So 3 out of what?
19.
Yeah, 3 out of 19. 1 out of 19. 4 out of 19. Unfortunately, 19 is really hard to divide. That's okay though.
Wait, there's 2 Utah fans? What the?
Oh, I screwed up somewhere. That's supposed to be 9. It's supposed to be 4.
So you're not a bandwagon like everyone else? All the other Oregon fans?
I'm not a bandwagon.
All right, what's 3 divided by 19?
0.157, so you can round it like.
Okay, so 16% male BYU fans. So about 5. What's 1 divided by 19? 5 point what? 5. Y'all have a calculator, right? Welcome to math. What's 1 divided by 19?
A number.
Very small. 21.744.
What's that? It's 0.16, yeah. 1 divided by 19. 5 point or 0.05, 0.0.
5263155.
5 roughly.
1 divided by 19 is 0.05.
Okay, so that means this is going to be about 1. Now, these should add up to 1 when we're finished. Are they going to be off just a little bit? It should be really close, right? Why would they be off?
Because how you're calculating rounds.
Because we're rounding. Yeah, we're cutting it off. This would be a 1. What's 4 divided by 19? 0.21. Is that all right? And is 2 divided by 19 point 1 what? 1/4? Anyone? And
Well, 0.105.
0.10.
Like 0.11. If you just
Yeah, but
4 divided by 19 on my calculator is 0.21.
you should buy a new calculator.
You can bring it up. I can look at it. 9 divided by 19.
0.47.
4 divided by 19 is 0.21. 13 divided by 19 is, thank you,
0.67. Oh, it's 13. Hang on, my bad.
okay, something like that. All right, so now question number 1. How many females in our class like BYU? 1. What percentage of females in our class like BYU? The percentage of females? 5%. How many males in our class like the U of U? 1. What percentage of males in our class like neither? Males neither? 47%. So by changing these, we get a count. Changing them into a percentage, it makes down here a lot easier, right? Just throw them all on there. Not that they're hard anyway, but... Okay, for the following questions, I'm going to pick any student out of random. Okay, so what's the probability that they are female and they like neither? So that's going to be an intersection. We have to find on here that they are female and they don't like either. Where is that box? So female, right here, right? So the chance, the probability that that's going to happen is 21%.
Are all your other classes much higher than us?
Higher. This is the first time I've taught this. I don't know what it'll be like. I just personally couldn't commit to BYU or the U, so I had to add the neither category. What's the probability that they are male and like BYU? So male, BYU, roughly 16%. What is the probability that they do not like? So this is a complement question, right? What's the probability that they do not like BYU? That means it doesn't clarify with gender, right? BYU fans are right here. So we're going to say 1 minus the BYU fans because that would be everything else. 79%. Is that okay? Because remember, the complement and the regular set add up to be 1, so we can just subtract. What is the probability that they like BYU or are a female? So this one's a little bit harder, right? How many people, let's look really quick, like BYU or are female? That's those two groups, right? How many people are involved in those two groups? 9. You have to be really careful. You can't count that one twice, right? So there are 9 people in that group out of how many? 19.
There's one right there.
9 out of 19 is 47%. Very good. So right here, kind of, it gets a little more complicated. Again, this one more time. What is the probability that they either like BYU or are a female? So there's 2 different kinds of questions. If I'm asking BYU or a female, it could be in either category. They either have to like BYU or they're a female. Either of those 2 categories. The other question you might see is what's the probability that they are female and they like BYU? That one is just right here. So the and has to be the overlap. That's the intersection, the upside down U. The or could be either column. See the difference? Okay, moving on. So this time I'm going to give you data about gender and pierced ears. So find the following probabilities. What's the probability that a student picked at random has pierced ears? What would you do? Where am I going to? 103. So it doesn't specify between male and female, right? We only care about if the person picked has pierced ears. So we're going to look at that 103, put it out of the total, 178, and figure out the percentage.
Well, 58%.
Roughly 58% of the table, of the study, had pierced ears. Just kind of blurry. There we go. Okay, what's the probability that the person is a male with pierced ears? Where am I going to look there? So male, 19, yes, they have pierced ears.
18%.
So 19 out of what?
103.
Oh, 19 out of 178. It's a different kind of question. 0.0, point. Okay, so 0.10 would give us 10%. What you just did, Austin, the 19 out of 103, that's called a conditional probability because you're putting a condition on it. What you just did was, what's the probability that it is a male and they have pierced ears? So it's a little bit different wording. In that one, we're only looking at one column when we do the probability. We'll get there in just 1 second. Okay, at part D, or let's do C, what is the probability that it is male or they have pierced ears? So on this one, we're going to look at both of the men data, and yes, they have pierced ears. We're looking at that intersection, or that union right there. The word is or.
So it's out of 1.
So this one's still going to be out of 178, because it's the total number of people. How many people are in each of those categories, or total?
9.
So 90 plus 84, 174. Carson's like, I've been saying that for 3 years, thank you. High percentage that they either are a male or yes, they have pierced ears. We could have also done everything minus the 4, right? We've been just as fast. What percentage is that? 90. What percent?
98% around.
Roughly 98% are either a male or they have pierced ears. What's the chance that they're going to be female?
88.
No qualifier on the oh, just female. So there are 88 girls out of the 178. The study was taken before we had to worry about all of that. Part E, probability that they are female and they have pierced ears would be what? $84 out of the 178, which would be what, 48%? 47? What is it? The calculator man's on a cell phone right now. Somebody else needs to calculate it.
60.
What is it?
Wait,
What?
what? Oh, 84.
47%?
Oh, never mind.
Yeah, I got 47.
Okay, cool. Totally just called you out on my recording. Awesome.
Yep.
There it is. Part F, what is the probability that they are a female or they have pierced ears? So where am I going to look here? Female, both of those. And yes, they have pierced ears? Or they have, so this one. It's everything besides my 71, right? Is that okay?
I know it.
Yes? No? Is that okay? It's everything besides the 71? So would it be 106, 107, sorry, out of the 178? 60? So So that's how you work a two-way table. Any questions on that? Are you okay with the or and the and? The intersection is where the two lines meet. The or, you could take either column or row. Just make sure you don't add the overlap twice. Okay, so now we're going to talk about something called a conditional probability. A conditional probability happens when you're putting a condition on something. So you'll have something like, given that it's a girl, so we know it's a girl, what's the probability that she has earrings? Given that they don't have ears pierced, what's the probability that it's a boy? So we're putting a condition on it. Conditional probability, the probability that one event happens given that the other event is already known or has already taken place. It's called a conditional probability. Suppose we know that event A happens, then the probability that event B happens given event A is denoted by this. Probability of event A happening, so it looks just like we did before. The straight line right there means given B. The cool thing about this, and let's do an example, let's go to the one right above it. So what's the probability of, given that it's a girl, what's the probability that they don't have their ears pierced? Well, if it's a girl, it's going to be out of 88 because that's how many girls there are. And there's 4 that don't have their ears pierced. So if I wrote it like this, it would be 488. And if you turn it on its side, it's a fraction, right? 4 out of 88. And then you just find the percent. So if you write it in the problem, how many girls don't have their ears pierced out of how many girls there are total, you have your percentage. So let's try example 3. Using the same information from the table above, if we know that a randomly selected student has their ears pierced, what is the probability that the student is male? So first, how many students have their ears pierced? 103. We restrict our interest to just this group. They're the only group we care about. And then how many males are there with pierced ears?
19.
So 19. We can say the probability of a male given ears pierced would be what? 19 out of 103. You're putting a classification on it. You're putting a special interest in one group. Yeah, we can change it to a fraction or to a percentage.
I mean, we don't have to.
We don't have to. I don't care. We can leave it like that as long as you know how to. I'm fine. Example 4. If we know that a randomly selected student is male, what's the probability that the student has their ears pierced? So first, how many students are male? 90. We restrict our interest to just this group, and then how many of those males have pierced ears? 19. So we can say the probability of having their ears pierced, given that they're male, is 19 out of 90. Now you have to be really careful because those two questions are very similar. Let's read them one more time. On example 3, if we know the randomly selected student has pierced ears. So this one, we're restricting our group to just those that have pierced ears. And then we're saying the males out of the pierced ears. This one right here, we're restricting our groups to what? The males, and we're looking how many have pierced ears from that. So it's kind of reverse. Very, very close. So let's try a couple of these really quick. I think that was supposed to be deleted off. Because it's the exact same thing as what above. So let's move on. And that didn't work either. Look at that. Random, okay. So using the notation. Okay, let's jump up to right here. So we look at this table one more time. Using the notation, probability of males, probability of pierced ears, probability of a male given has pierced ears. We're going to denote it like this. Male given the piercing. So, again, if I'm only looking at how many males have pierced ears, it would be 90, right? And how many of them do? 19. Oh, sorry, no, back up. If I'm only looking at the number of pierced ears, what would that be?
103.
103, sorry.
Dalton.
And how many of them have are males?
19.
19. So this one we're restricting it to the pierced ears. This one we're restricting it to the males. So how many males are there?
90.
So that one's going to be the 90, and 19 of the 90 have the ears pierced. Okay, 2 more examples and I think we're done. Example 4, students at the University of New Harmony received 10,000 course grades last semester. So there's basically 10,000 people that they have scores from. The 2A table below breaks down these grades by which school of the university were taught. So we look at the liberal arts school and we look at the engineering school and we're looking at the health and human services. In the liberal arts, 2,000-ish got an A in their class, 1,900 got a B, and 2,200 got below a B. The engineering, 364 got an A, 432 have a B, and then 800 have below a B. And health, and so on. So the first thing we want to do is come up with the totals. On your own really quick, will you total the columns, total the rows, so we can get those numbers? So I got 6,300 for liberal arts.
And that's 1,600, 2,100.
And then it should be the 10,000. Okay, what about A's? You guys gotten that one yet? 3392, 21, 2952, 3652. What? 50. Okay. 3256. Okay. So, what's the probability that they are a liberal arts student? What would we need to know? There's no condition. We need to know how many liberal arts students there are. 6,300 divided by the total number of students. Find a percentage. %. Now, you don't have to worry about any sort of conditions until you see the notation like this. Find the probability that, what does this mean? EL. What does E stand for? Does it tell us? E, the grades come from an E engineering course, and L, the grades are lower than a B. So this is my L column right here, right? This is my E column, or row. So find the probability that the grade comes from an engineering course and it's given that it's lower than a B. So what's the denominator? This is what's given, right? Right there's the denominator. So the denominator is everything below a B. 3,256. And then we put our engineers on top of that, which would be what? 800. So the probability that they're an engineer and score lower than a B would be right here. Yeah.
It's not 3,256. It's 3,656.
Oh, sorry. Thank you. Okay, so divide that out. What do we get? 21. Sorry. Yeah, 22, 21.9. So when I'm looking at this, the L is very specific. It's going to come from one little box. The E is the column total. Okay, so this one's saying, What's the probability that, given it's an engineer, they have a score lower than a B? So given the engineer, which means we need to know how many engineers there are. 1,600. Now what's the probability that they have lower than a B given they're an engineer? Oh, sad. 50% of engineers aren't scoring an A or a B. Why would you think that's true? Because engineering's hard, right?
It is.
Yeah. My husband's an engineer, and it would be so irritating because there was our very first semester at Utah State, we were both in the exact same probability class, taught by a Russian man who I couldn't understand what he was saying. His name was Dr. Kokoschka. For real.
Sounds like a terrorist.
I tried so hard to understand what was going on. I know. I studied, and my husband didn't even look at it really. Like, he was in class and then he took the test.
Like I do.
Yeah, except we don't have phones then. He got an A in the class, and I got a D, and I had to retake it. I worked so hard, and he's like, well, it's easier than my other classes.
Gene, that's like
Dang it.
history. He always falls asleep every
Then you
class,
can answer
and then
it.
he gets an A.
There was another class I had to take. It was my something analysis class, I don't remember. My husband wasn't taking it, but I'd ask him for help every once in a while, and he could help me, and he had never taken the class before. And his excuse was, well, it's easier than my engineering classes. Shut up, jerk. Really? Yeah, engineering's hard, so I would expect that maybe not everybody get an A's. Okay, last example, the Titanic. The RMS Titanic has 2,224 people on board ship, including the children. Yet there was a lifeboat space for only 1,178. Various factors on that fateful day also made it so many lifeboats were not full when they were launched. The following table does not include the crew. So these are only the passengers. Number 13, how many males, event M, survived?
338.
Yeah, males survived 338. Yeah. Yep. How many females survived? 316. Now you're like, oh, that's about equal, but is it really equal?
No.
No, why? Because there are a whole lot more males on board than there were females, right? And most of these males that survived were probably what? Children, right? Because what happens? That the women and the children went first, right? They were saved first. Okay, so how many total people survived event S? So we're going to use all of these numbers right here to answer these questions. What's the probability that it was a male on the ship? That's what this means right here.
1690.
Okay, so 1690 out of our what?
2150.
What's the probability that they survived? So we take all of our survivors. Now don't forget on these, no condition is being made. That's it. 654 people survived out of the 2115 passengers. So now 17, 18, 19, 20, we're going to be looking at conditions. What's the probability that they survived given it was a male? We know that it was a male. What's the probability that they survived? What goes on bottom? It's probably easier to look at the bottom first. I look at how many males were there, 1690. On top, the survive, 338. Let's actually calculate a percentage here because I'm curious. Given it was male, 20% of the males survived. Okay, this one, is there a condition on it?
No.
No, so what do you do?
Do it. Digits.
So females, 425 out of the total passenger. So not as many females were on board. What does this mean? What's the probability that what? Given it was a female, they survived. So do the bottom first. What goes on bottom? Good. Given it was a female, always do the denominator first so that you know which column or row to look at. Given it was a female, how many survived? By the way, will this number ever be more than 1? Yeah, no, right?
It's like 74% of the women.
So what if it's,
Then you've made a mistake.
what if it's bunny population?
110% of people that pass don't, or anyway, don't know. There's one thing I've seen that was like 4 out of every 3 people don't understand fractions or something like that. Kind of similar. Okay, what about this one? What does this mean? Given it's a what?
Female.
Nope. Given that it's a survivor,
Survivor.
what's the probability that it's female? So that second number is what's going on bottom. Probability that it's a survivor. Probability that they were female. Ish. Okay, one last one. Oh, just kidding. That was it. So historically, when populations are in danger, societies protect women. Does the Titanic data support this priority?
Yes.
Yeah. A much higher percentage of where is it? Right here. This right here is what's going to show it, right? Given they were male, what's the percentage that they survived? It was 20%. 20% of the males survived. Let's do that one with the female. Have we done that one? Right here. 74% of the females survived. All right, is that it? Fantastic.
You know what I just thought of?
31 minutes.
When you were talking about when you're